Hi, my name is Al from Grayson Industrial Test. We're excited today to show you our newest machine. This machine does weld inspection of axle tube assemblies, otherwise more commonly known as a drive shaft. This machine has two different technologies to automate the process of weld inspection. The end caps are welded to the tube. In the process of welding, sometimes there's a gap or the weld doesn't penetrate deep enough. There's a laser profiler that will scan the outer surface of the weld as the part rotates, and will do 360 degrees of outer surface weld inspection. The software for the laser profiler has been trained to know the difference between the shapes of a good part versus a bad part when it views the outer surface of the weld. Once the part is rotated far enough to inspect the outer surface of the weld, the machine will bring in the ultrasonic equipment. The ultrasonic equipment is equipped with a transmitter and a receiver. We will shoot an ultrasonic signal into the weld, penetrating the weld and examining the weld depth. The receiver will pick up that signal and that will be processed by an instrument. The instrument will decide if the signal's strong enough, then the weld has penetrated deep enough. That will happen while we rotate another 360 degrees. After the laser profiler and the ultrasonic inspections are complete, the machine will evaluate all the data, and if it deems that the part has passed, it will illuminate the green button, and then it will unclamp the part and the operator is free to unload the part. This is the control panel for the machine. This will give you an overview of the status of the part and all of its measurements, as well as an overall pass-fail indicator. And this button will also indicate whether or not the part is passed or failed. On a good part, it'll be green and it'll illuminate red for a failed part. I'm now going to cycle the machine. The operator manually loads the part into the machine and biases the part to the left. There's a locating detail that the operator will slide the part against to know that it's in position. First, we scan the barcode, which contains the serial number of the part. Once I initiate the cycle, the clamps will close and grab the part and locate the part vertically. Then the yokes will close and will close in on the yoke assembly. That's what locates the part radially and left and right. And then the part will rotate and it's driven from the yoke end. The operator scans the barcode, giving the machine the serial number of the part. Then we initiate the cycle. The clamps close. The yokes grip the part and locate. The first rotation, the Keyence profilers are scanning the laser from the outside. Then the ultrasonics lift and scan the weld penetration. If the part's good, after the machine evaluates all the data, the green light will illuminate after the part is unclamped. This tells the operator that the part is good. The operator now is free to unload the part and load the next production part. At this point, the machine illuminates the red button to let the operator know that this part is a reject. The operator is free to unload the rejected part. The screen will provide a summary of the readings from the part, and you can see there's a couple readings that are in red, indicating that those are the criteria by which it has failed the part. This instrument has a horizontal line indicating the threshold for the signal. If the signal were to drop during rotation below the horizontal line, we would flag this part as a reject part. This machine is also capable of testing parts of different diameter and different lengths. The equipment is movable to accommodate different lengths by being able to slide the tooling into different positions. We're now set up to accommodate a shorter length part. Different diameter parts are automatically covered by the concept that the clamping mechanism is centering and equalizing, so it's always going to bring the part to the center line. This machine is equipped to test up to 24 different parts. There's a recipe manager on the machine. The recipe manager will tell the machine about each one of the 24 different parts. Each part can have its own threshold, its own tolerances, and it also contains a different part number for each part. This machine is gathering data about each and every part that it tests and attaches it to a date and time stamp and a serial number. That information is communicated to a plant database at the end of the cycle. This machine has two control panels. The panel on the left is just an HMI, or human to machine interface. The human to machine interface gives just a general guide for the operator to show them what's happening with the part, and also a place to set up parts and to modify tolerances. The rest of the general machine controls are off to the side on the right-hand side of the machine. Basic power on-off, another emergency stop, and lights are all controlled from the side of the machine. Also on this side of the machine is another screen. This screen is dedicated to configuring and to monitoring the laser profilers that are on the machine. The screen shows you a little bit about a part that was scanned and a little bit about the evaluation process. This screen is locked out from the operators. However, a technician can come in here and modify the evaluation technique used by the laser profilers. The Weld inspection machine has been engineered to be able to bring together, in a simplified manner, a complex array of testing and measurement. Behind the scenes, there are a lot of tests that are done at a very high rate of speed. The Weld inspection machine simplifies all the results and consolidates them into a report that's user-friendly for the operator and a single go, no-go indicator light on the machine. The Weld inspection machine also is versatile in the fact that it can be modified to inspect up to 24 different part styles. This eliminates the need for the customer to have other dedicated capital equipment for small production runs. Thank you for your time.